So we're doing a step-by-step for optimization problems. And again, we're talking about three types of problems: XY problems, geometry problems, min-distance problems. I always give a geometry problem and a min-distance problem. So you'll have one on a quiz, you'll have one on the midterm, right? I want to do a step-by-step here for this process. Of course, you're going to read the problem. And remember what we said, these are applications of derivatives, so they're all word problems, basically, right? Read the problem and find an equation and an expression. To be optimized. And that expression will be in x and y, or whatever two variables you choose to deal with, right? Step 2, solve the equation for y and create a function of x with the expression, right? Solve the equation for y and create a function of x. So far, yes? You with me? So we read the problem. Maybe we have to draw a picture, but we should be able to come up with some kind of equation, some kind of expression, right? That's step 1. Step 2, take the equation and solve it for y, and then substitute into the expression to create a function of x. What did I do with that function of x? I did basically a first derivative test and a second derivative test for local min-max, right? So find f prime and the critical value. Answer the question, answer all parts of the question. Step 5, double check your critical value in f double prime, right? Show, I'll call it C1, right? Find f prime in the critical value C1. Show that f double prime of C1 is a min or max. Make a conclusion. Every one of these problems I'm teaching you in chapter 4 has got this giant, or this process, right? And so you need to know all of this process, or even better, know it and have it written on your formula sheet, right? And have some example problems written down too, right? So we're running out of room on this formula sheet, but you should be working on it. It should be a work of art, right? Should have your whole course on this one page of paper. The entire course, every type of problem we've ever done. All right, should we do another geometry, or do you want to move right on to the very difficult min-distance? No. Geometry. Yes? Yes? So the typical one that we always like to do is a box, right? I'm making boxes for Amazon, right? I want to, of course, if I have a volume that I want, what do I want to make sure I do? I want to make sure I use the least amount of cardboard, right, to get that volume, because the cardboard costs me money. I'm trying to make a profit, right? So I'm trying to minimize my cost of the cardboard and get a certain volume, right? So that type of problem, let's see if we got one here. Here it is, number 17. A box with a square base. So you can picture the cardboard box. It's a square base, right? And it's a certain height. But the top is open. There's no cardboard at the top. You with me? So I have a square base and a certain height for the box, right? And the top of the box has no cardboard. It's open box. So this is 4.6, number 17. I've got a square base, so an x by x, right? And I've got an open top, but I have a certain height y. Right? And that top is completely open, right? How you doing? You with me? We okay? Good. What do I know so far? I know that the volume is 32,000 centimeters cubed, right? So what do I have for volume here? X by y, right? So x squared y is 32,000. Yes? So there's my equation. Yes, everybody okay? I want a box that minimizes the amount of material. So the question is, how many sides do I have here? You agree 5 sides? And one side is x by x, and the other sides are x by what? X by y. So I want to minimize x squared plus 4xy. There's my expression. Yes, you okay with this? It's the 5 sides of the box, right? The base is x by x. All of the other 4 sides are x by y's. Everyone okay here? So I had a picture. From the picture and from the information, I figured out an equation and an expression, right? So there's step 1. Step 2, solve the equation for y, right? So y equals 32,000 over x squared. Is that right, 32,000? Yeah. And so now I want to minimize f of x equal to x squared plus 4 times x times 32,000 over x squared. How we doing? Nice. So find our derivative. F prime of x is 2x minus 128,000 over x squared. I'm doing that derivative pretty quickly, but I think you're okay with that. Am I right? Derivative of x squared is 2x. That's not a problem, right? We're okay? I need an LCD, so I need a 2x cubed minus 128,000. And to get my critical, I set my numerator equal to 0, right? So it looks like I get what? What is it, 4,000? Cube root of 64 is 4, is that right? Ow. 40, yes, you're right. Thank you. Thank you. 40 centimeters, right? How we doing? We okay? And you'll see it's kind of a boring box at the end, but so what did I say to do? I need to do a couple things. I don't have to do them in any particular order. I have to find all the other pieces of the problem. I have to show that 40 is going to give me a minimum, right? And I have to write a conclusion. Yes? So I think it's kind of easy to get my second derivative right away here. Who's got my second derivative for me? Thank you very much. So f double prime of 40 is certainly positive, right? Yes? I don't care what actual number it is. I know it's positive, right? So positive people smile, so I know it's a min. Got that part done. What else do I have to find from the problem? I have to find the dimensions of the box, right? And the amount of surface area of the box. So I know x squared y has to be 32,000, right? Say again? 20? You found it already? Thank you. And so I know I've got to have y is 3,200 over 40 squared, right? Yes? We get, what you got 20? Really?
What do you get?
I got a half.
What?
Did I do something wrong? Oh, 40 squared. Shoot. 3,200. Thank you. Divided by 40 squared. 20. Thank you. I know x is 40 centimeters. I know y is 20 centimeters, right? I know the area, sorry, the volume, 40 squared times 20, which of course is at 32,000 centimeters cubed, right? And I need the surface area. Right? My surface area was what? X squared plus 4xy. So 40 squared plus 4 times 40 times 20. $4,800 centimeters squared, right? Surface area is 2 dimensions. Volume's 3 dimensions, right? Each length is 1 dimension. Yes? And then conclusion. I don't want to feel like doing it though. I want to write everything up nice. Yes, I got mad scroll skills. Had enough? Nice. Oh my God, it's so boring. Remember, I told you, make sure you're taking 500 milligrams of something before these classes because you're going to have a headache. If you don't have a headache, maybe go see a doctor. Who's absent today? Brian's absent. Brian and Sina. I think everybody else is here. Brian is out. Other Brian is out, and Sina is out. Okay, you ready for the tough problem? We'll end a little early today because it's just too much to do. But if you need to take a break, if you need to go get something to drink, I don't blame you. Okay. If you want to go bang your head against the wall again like last Thursday, that's fine too. Just try not to make too much noise. All right, I want to do a min distance problem. It's my favorite problem. It's always on every test. So it'll most likely be on your second midterm. Maybe I would put it on a quiz. Probably like a box problem for the quiz. And then the min distance problem for the test. And depending on how we do, it would show up on the exam, final exam, right? Remember, what am I putting on the final exam? I'm putting on all of the problems that we've had the most trouble with, right? So, meaning we had trouble with finding a derivative using a limit, right? So I'll put one on the final exam, but I'll change the function, right? So that's the idea for the final exam. So if you can do all of the problems on your two midterms and your quizzes, you'll be ready for the final exam, okay? And what's going to change is I'll change the function, right? Say again? No. I don't like easy problems. Easy problems are boring. You don't walk out of a test with easy problems on it and feel proud. You walk out of a tough test, and that's when you say, I got this stuff, right? I mean, the functions, I can't give you any different functions that are more difficult. They're all difficult, aren't they? Yeah. All right, here we go. Min distance problem.
I always feel like you are calling me.
One more time.
I always feel like you are calling me.
Oh, because I say min. Yeah. Sorry. That's funny. So minimum distance problem, okay? I gotta stop my recording. It's just not gonna be able to handle it.